Cool. So let us understand what do we mean by hashing. So what is hashing? Soulless space and a huge range to store. This is what hashing is. So it says that you have just certain amount of space. Let's say you just have this much of space. Okay. And somebody tells you that, hey, I am going to give you some numbers which will be in the range from 1 to 10 raised to power 6. So I just have 4 space. Okay. And somebody told me that, hey, I'll give you the numbers which will be in range from 1 to 10 raised to power 6. Okay. And that guy also told me that along with the number, I'll give you one secret tip about that number. So let's say he told me that, hey, I'll give you a number like 53, and I'll tell you that which number is the friend of 53, just for an example. Which number is the friend of 53? So let's say the friend of 53 is 93. And then somebody says that, hey, I'll give you a number, second number, which can be like 100, and I'll tell you that the friend of this is this. And the third number will be like 99, and the friend of this is -1. And the last number will be like 10 raised to power 5, and its friend is also, let's say, -1. So somebody tells me that, hey, these are the numbers and these are the friends. So I can think of these things as keys and these things as values. Okay. And then that guy wants me to store this piece of information somewhere in some data structure and store it in a way that it is very easily to retrieve it also. Retrieve it means that tomorrow if somebody asks me that, hey, you tell me the value corresponding to 99, then it should not take me too long to answer it. Okay. So that is what the requirement is. So what do you think can I use over here? Forget about hash maps for a while. So simplifying the question again, like somebody has simply given me lot of key value pairs, and by this statement I mean that the range of key is huge, much huge as compared to the amount of space that I have. My key can be anything in between 1 to 10 raised to power 6. That is the piece of information that I have. Okay. But let's say there will be very less keys. There will not be 10 raised to power 6 keys. There will just be 4 keys, but their range is very high. And then somebody tells me that along with the key, I'll give you value. And now I want you to store this information somewhere. So can you suggest me some data structures that I can very easily use to store this information? Oh, very good, very good. So I got 2 answers, and which looks very promising. So the first answer is, the second answer which Shivani has written, she is saying that they can be thought of as a pair. Everything can be thought of as a pair because key value eventually is a pair only. So I can simply create a vector of pair of integer and integer. So this is the vector, vec, and it contains many pairs. Now the moment I got this, I can do vector dot pushback. I can push this pair. You can create pair like this in C++. You can see in other languages also how you can do that. So this way you can create, and given something, you can store it very easily. Okay. Can somebody tell me that what are the problems with this approach? What are the problems with using this vector as an instrument of storing key value pair? Will something go wrong if I use vector for storing key value pairs? And if it will go wrong, where will it go wrong? Yeah, searching will be very tedious. Retrieving will be very tedious. Cool. That makes a lot of sense. So just think of it in this way, that if I have stored these information in a vector, okay, so storing part is called as insertion. Okay, so what is the time complexity of insertion? You are always inserting at the back of the vector, pushing at the back of the vector. So how much time does it take to push something at the back of vector? Why order n? It is just order 1, right? You push it at the back of vector, that is always free slot. Okay, no adjustments required. So insert is very quick. This is order 1. Okay, but what about search? If somebody tells me that, hey, get me the key corresponding to 100. If somebody asks me to get him the key corresponding to 100, now I do not know where this 100 is located. I mean, whether it is present in vec 0 or present in vec 1, for which value of j, vec j dot first is equal to 100, this I don't know. Okay, and because I don't know this, I'll have to perform a linear search. So the major problem is that the process of searching a value from a given key will be extremely tedious. Okay, that is going to be very, very bad. So although one thing is order 1, insert is order 1, but the other thing is order n. So I'm sad about it, I'm not happy with it. So what can I do? Tell me one thing, there is another thing which is even more bad about this. Think on your own. And that is not bad from, that is bad from functional perspective also, but that is much worse from design perspective. Very good. Redundancy of key. Would you want that your key, which is supposed to be a unique identifier, the way primary key is a unique identifier in database, so would you want something like key to be duplicated? Would you want a user to insert? Yeah, you would not want to do that, because if somebody has inserted for 53 the value 93, and later on if he wants to insert 53, 70, then it should ideally be treated as an update. Okay, and what does the update means? If the key already exists, then change this value to the new value that the user wants. Okay, so basically this is an update, and this update will not be done if you keep pushing everything at the back of the vector. So from this perspective also this is not good, but I think I can solve this problem very easily. By enhancing the complexity of my insert to something else, I can solve this problem, yes or no? I can solve this problem, right? So whenever somebody tries to insert something, then rather than just pushing it back to the vector, I can first scan through the vector to see whether it already exists or not. And if it already exists, if that key already exists, I'll simply update its value. So this way I can solve for this problem. But what happens if you solve for this problem, then both of these things become order n and order n each. So the reason I am discussing these things is because in certain interviews, your interviewer would be interested in knowing your depth in a data structure rather than just your problem solving skills. So he would want to know why HashMap, why not something else? He would challenge you to use something else. And then you will use something else, and then he'll ask you to find faults with that. And if you're not able to find faults with that, that means you simply mugged up hash maps. You did not accept it something which was actually needed. Okay? So this kind of discussion is very important. Always question yourself, why do I need HashMap? Why can't I do the same thing that HashMap does using something else? So one of you suggested this, and we learned why this thing can't be applicable. Anyways, move ahead. So after this, next thing that one of you suggested is to use an array, and in that array what will you do? Let's say the key is this, then at array of key you will place the value. So in that array what will happen, that at index 53 I'll get 70, at index 100 I'll get 10 raised to power 6. This is just like, you know, how you guys used to build frequency array and those kind of things. This is just like that. So can somebody tell me the time complexity of insert? How much does the insert take in this case? It is just order 1, right? Okay, and will insert in this case handle updates also very easily? It will, because tomorrow if you want to change 53's value to 80, the moment you do this thing, you will hit this target only, and you will change this to whatever you want, right? And what is the time complexity of get? If somebody wants to do a get for 100, how much time does it take you to return? Just order 1, right? Cool, because lookup from an array is very fast. Lookup from an array is order 1. So basically here, if you take a look, here you are treating the index of array as the key of the pair that you want to insert, right? You're treating index of the array as the key, and basically that key itself helps you to get the address. Key gets you the address in the array where value could be found for that particular key. What is it which is wrong about this approach? Not wrong, what is it something which is bad about this approach? Yeah, there will be a lot of memory wastage because I said so less space. So less space means that at times, if let's say this is very large, then your computer doesn't have space to declare an array of size 10 raised to power 10, but your computer does have space to store 4 numbers. Now just because those 4 numbers are in this range, so because of the fear of this range, you end up creating an array of size 10 raised to power 10 that is nonsense. Okay, so that you should not do. If you're doing that, a lot of space is going to get wasted, and also at times you won't have much space. So both the approaches had their cons. So this one had performance based cons with respect to time complexity, and this one had performance based cons with respect to space complexity, right? That it used to spike up my space. So first of all, these are the popular solutions that I hear. So today we are going to learn HashMap based implementation, which will make life very easy for you. Now, the first lesson for you guys is from today onwards, to overcome the fear of hashing, you have to use maps. It might so happen that there is a question which you can do using arrays also instead of using HashMap. But I would recommend you to use HashMap just to get over your fear. Because HashMap is a very important data structures from interview perspective. It's really, really important, okay? And it is a data structure which is used in industries also. So industries do not use a lot of maybe trees or something like graphs, but HashMap is very, very oftenly used. So there are 2 kinds of map. Let's not talk about HashMap for now. There are 2 kinds of map. First is HashMap, and second is TreeMap. So how many of you have heard about this second thing, TreeMap? Just type in yes, those of you have heard of this. This is present in every language. TreeMap is present in every language. Okay. This is the real map, I would say. This is the real map. And this is also called as hash table. Some people call it hash table. Okay. This is nothing but a tree actually. This is a very, very efficient and self-balancing binary search tree. If you do not understand any term, do not worry, we'll study later. But this is self-balancing binary search tree. Okay. Map name is confusing over here. But since people have coined it, we use it. Okay. So this is a tree map, but this is not actually a map. This is purely a tree only. A special kind of tree which can balance its height always. Always, ensure that the height is log of the number of nodes. Cool. So let us understand, we will not be talking about this for now, we will be talking about this, okay? Cool. So, key value thing is a pair, okay? Is a pair. So let's say somebody wants to insert K1V1. Somebody wants to insert this entry for key 100 and value let's say 200. So what is done is that, what do the hash maps do? They initialize some minimal space in the memory. It could be like space to accommodate 8 pairs or space to accommodate 16 pairs. It depends upon the language and it depends upon the settings also. The way it happens in vector, do you remember? In vector the initial size is equal to 8 or something, and then it doubles every time. When it sees that more elements are coming, then the size of vector automatically doubles. So that is what happens with map also. Initially the size is just this much, okay, which could be let's say x, and when it sees that too many elements have come, then it will try to double itself. Okay, in some languages make itself 1.5 of what it is. It depends upon language. Okay, cool. So let's say these are the slots, and the slots are let's say 0, 1, 2, 3, 4. There are just 5 slots, so I number them from 0 to 4. So what happens the moment a key comes, the moment a record comes, then your hash map uses an algorithm called as hash function. This is also called as hash code. So it contains some algorithm, some pieces of code inside it. to determine that which slot should this pair go to, and that determination is done on the basis of key. Why? Because key is the unique identifier, value is the not unique identifier, value is not the unique identifier. So based on the key, just think of it in this way, that this hash function will take in this key and perform some hash computation. Now that hash computation could be order 1 operation also, and sometimes it can be sometimes it can be more than that also. So what should be the output of this? The output of this should be slot number, and that slot number will be a number which will lie in between 0 to 4. So whatever is the slot number that it obtained for this key, it will put this pair at that particular slot. Okay, this is how it goes on and on. So hash functions can be many, there can be different hash functions. I can give you one very simple example of hash function, where hash function takes the key k, and what it returns is k mod n, where n is the number of slots that it currently has. So whatever is the k mod n, at that slot this pair is going to go. Okay, this hash function is not the hash function which is actually used by the hash maps that your libraries implement. They implement a much robust hash function. I'll tell you what is the meaning of robust hash function. I just gave this for simplicity's sake. Okay, now let us take some example. Let us say a pair called as 6, 9 comes. Can you tell me at which slot will it go in this? At which slot it will go? Yeah. So this key is 6 and the value of n is equal to 5, right? So if it does 6 mod 5, it will get 1. So in the first slot, it will push this thing, which is 6, 9 will be pushed over here, right? Cool. Now let's say if something else comes, let's say something like 11, 2 comes. Can you tell me at which slot this one will go? Not 11, let's say 13, 2 comes. At which slot this one will go? 3, because 13 mod 5 is equal to how much? 3. So what will it do? At the third slot, it will send this pair, which is 13, 2. Let's say after this again something like 29, 7 comes. Where will it go? 29, 7 in which slot? So 29 mod 5 is equal to 4. So it will try to send in this thing over here. Okay, why the mod is being taken with n only? Because the slots can be from 0 to n minus 1 only. That is the reason. So again, whatever this function is, be it this simple function or some very complicated function, the output has to be something in between 0 to n minus 1, where n is the total amount of space that the hash function, slots that the hash function currently has. Okay, cool. Can somebody tell me what can go wrong with this approach? Let me ask you one simple question. If let's say after this 11, 0 comes, where will you want to put it according to this algorithm? Yes, you'd want to put it at again 1, because all of us studied that mod is cyclic. So whatever is x mod 5, x plus 5 mod 5 will also be that. X plus 10 mod 5 will also be that. So 11 mod 5 is equal to 1. So it would want to place this over here, but can it place it here? It cannot place it here because already there is something over here. Okay, so this is a case of collision. This is a case of collision. So all of you understand what collision is? Collision happens because of the nature of hash function. So generally people, your inbuilt unordered maps or inbuilt hash maps of Java, the hash functions that is written by the library writers, that is very robust, that tries to prevent collision as much as possible, although it is impossible to prevent it 100%. It can happen that for some cases some collisions do happen, right? But if hash function is very bad, if let's say hash function is something like this and you keep getting numbers like 6, 11, 16, 21, then all of them will undergo collision, right? So a good hash function means that function which prevents collision as far as possible. So this is a very important thing with respect to hash functions. Okay, now we will not go into details of, right now we will not go into those details that how are good hash functions implemented. It will be taught to you later. but not right now. For now, just assume that there are certain very, very good hash functions, and you can do some Google search. It will be a good learning for you that how to implement good hash functions. Okay, and it will be covered in a different kind of topic, not this. Cool. So another thing that we all should understand over here is that whenever the collision happens, what must happen? What are the different ways to handle this collision? Can somebody suggest me a way to handle this collision? I'm sure if you have heard of something, you can tell that thing. But if it is something that you thought on your own, that would be even better. So how many of you are thinking something like this, that hey, this thing belongs here, but if you can't put it here, then do one thing, create a new memory location, okay, and put this over there and just link it. So this is a very popular technique, and this is how the collisions are resolved, and this is called as chaining. So chaining means that if multiple pairs are being mapped to the same slot, let's say after this something like 16, 3 came, then 16 mod 5 is also when it belongs to the same slot. So corresponding to that, it will be created over here. And which kind of data structure will this be? Can you think of, although we have not taught it now, but what will it be? It will be a linked list. Yes, it will be a linked list, because so there will be different chunks of memory and linked to each other, right? So this is how it resolves the this problem of collision. So chaining is the way to go ahead. Okay, tell me one thing. What is it that is not so good about this chaining? If I chain it in this way, if I chain it by creating a linked list from here, what is it that is not so good? Searching. Very good. So searching will become difficult. So let's say there was another element like 21.4, and after so much you inserted 21.4 as well over here and linked it like this. Now let's say somebody says that, hey, get me the value corresponding to 16. So let's hold on and let's work gradually. What do you think? Whenever the get of a particular key has been called, what would be the first event to occur? When I receive a key corresponding to which I have to search a value, then first you would want to locate the slot in which this key is present, yes or no? And how can you determine that? So you can determine that by computing the hash of it. So whenever get is called, just like in the case of insert, there will be a hash computation. So hash computation happens both the times, whether you are inserting or you are getting. So first the hash of this will be computed using whatever the hash algorithm was, and it would see that, hey, it is present in first slot. Now it will go to this slot number 1, and now from here it will start a linear search. This is a linked list and it has to do a linear search over here. So it will linear search among the keys, and the moment it sees that this key is equal to this key, then whatever is the value, that value would be returned. Okay. Now tell me one thing. In the worst case, what can happen, that all the n elements that you have inserted, your hash function was so bad that it mapped them to the same slot and a long line got created. Can it happen or not? Tell me, yes or no. So if that happens in such a case, what will be the complexity of search? Because you'll have to do a linear traversal, okay, which will be a linear search, so it will be order n, right? So from this point of view, this chaining kind of thing is bad. It is not too good, okay? People have tried, computer scientists have tried immensely to resolve collision as efficiently as possible, but there is no deterministic solution to it, because this thing is obvious. You have 2 less rooms and too many guests. So you can't accommodate 1 guest per room. You have to do some kind of management. So they have tried to be as, flawless and as efficient as possible, but that efficiency has never been 100%. Okay. So this chaining is also not good with respect to that. But if, let's say, I want that the chains which are getting created, they are not too long, is there a way I can avoid that? How about I work with my hash function? If I improve my hash function such that the probability of collision reduces, in that case it will be ensured that the chains will not be too long. So this is a very important point, and this is the reason, this is the only reason why having a robust hash function is very important. However, writing it is a very mathematically challenging task, so it is internally already implemented for you. Now, just tell me one thing. What, according to you, would be the time complexity of insert? If let's say I have to insert something, insert a key value pair, what would be the time complexity of this? Okay, so somebody thinks order n. So those of you who are thinking order n, you are thinking that let's say a new entry comes for let's say 1, 9, then for 1 the slot will be this, and you will traverse till the end, and then you will link something like this. Are you thinking something like this? It is right to think, but I would say that please don't think like that, because what you can do is for every linked list, you can maintain a head pointer and you can maintain a tail pointer also. Yes or no? Can you maintain a tail pointer? Yes. If you have a tail pointer, then you just have to link the new node with this tail, and that will be order 1 operation. So insertion can still be handled in order 1 despite all this nonsense. But search cannot be handled in order 1. Did you get this point? This is a very important interview question also. So we learned chaining. Do you think there would be any other kind of technique also to handle this collision thing? Anything that comes to your mind? Anything better than chaining, do you feel? Would it be existing or something like that? Yeah. So there is a concept of probing. Okay. So I'll come to probing later, but I'll tell you one thing right now only. This thing is like a hash table. This is a table of what? Table of hashes. That is the reason it is also called as hash table. Called as HashMap in Java. And can somebody tell me by what name it is known in C++? What is the name for this in C++? Yes, in C++ this is called as unordered map. Unordered map. And in C++ what is TreeMap? TreeMap is nothing but ordered map. Okay, in unordered map, it is thought of that the average complexity, see, insert is always order 1, but the average complexity of get, average complexity or amortized complexity, whatever you say, that is order 1. Why that is order 1? Because the hash function is very robust. So the chances of collisions are extremely low. Okay, that is the reason. The way in vector, every time pushback is not order 1. When vector expands, it is like order of the size of vector, right? But in case of something like unordered map, the hash function is so robust that the collisions happen very, very infrequently, and because of that, the average case complexity of search is order 1, right? So this is a quite important point. And what would be the worst case? What would be the worst case if let's say worst case can happen anytime for anyone, right? So what would be the worst case of search? It would be order n, right? Cool. So this is a quite important thing to understand. So generally, if you have to choose between unordered and ordered map, then if order is not important for you, so ordered map, what it does, it stores the values based on the ordering of their keys. So it sorts them based on their keys, and that is how it stores them. But unordered map doesn't maintain any kind of order. Okay, so that is an important thing to understand. So do not confuse this with this, because this has no relationship with this. It has a totally different implementation. Okay, cool. So I'll come to unordered map later, but I'll tell you one important thing over here. So what happens as another way to resolve the collision is something like this. So instead of one hash function, there are multiple hash functions. Let's say there are m hash functions. Can somebody think after this what would be happening? If let's say I just do not give you one hash function, I give you multiple hash functions. Can you somehow use multiple hash functions to avoid the, or to resolve the collision? So I can say something like this. When somebody tries to insert, let's say 104, then I'll find the hash of 100 using hash function 1. Okay, everyone now look at the board. I'll find the hash of this using hash function 1. If this causes a collision, I'll come here. If this causes a collision, I'll come here. If this causes a collision, I'll come here. So I'll linearly iterate over my hash functions. And the moment I see that there is a hash function, let's say hash function 7, which did not cause a collision, then I'll place the key corresponding to that in the particular slot. But you should ask me a question over here. I'm waiting for that question. What can be the worst case in this situation? Tell me. Can it not happen that all of them cause collisions? Is that possible or not? Yes, that is a good thing. And even better than that is the question that Neeraj has asked, that let's say you used it to insert. Now while you are doing a get of, let's say, 100, what will you do? Can somebody tell me what will you do when you are doing a get of 100? Searching will be difficult. Yes, because in that case, ideally, in the most brute force manner, it will first compute the hash of this using hash function 1, traverse that slot. If did not get, then use this, then use this, then use this, then finally uses this, and it will be like, crazy amount of searches. Okay, now you tell me, is there a better way to handle this? Can I do something like this? Let's say I inserted using hash function 7. Let's say I inserted using hash function 7. If I inserted using hash function 7, then I'll remember it that for this particular key, the hash function that was used by hash function number 7. So if there is a get for 100, I'll just use this thing to calculate the hash and iterate in that slot. So this is the way it is implemented, but again, like the problem here is that what if all hash functions cause collision? So even this can be, order in worst case. So even this also is not a foolproof solution. Okay, there is another solution to it. See, if you try to technically understand that why this is not working is because what do you want to do? You want to do efficient hashing, right? You want to do efficient hashing. For that, what you are using? Hash function, right? Now hash function has a problem, and to solve that problem, you are using another hash function which can have same problem. So there is a deadlock over here. So the problem will not be solved, right? So the hash function has a problem, and to solve the problem with that hash function, you are using other hash functions. So what if those also have the same problem? They will have, because if it could have been solvable, it would have been solvable for all, and you would not have opted for all, right? So these are non-deterministic approaches to solve this problem. Non-deterministic means there is no guarantee that the guy will be alive or dead. Okay, can be alive, can be dead, it can be anything, right? So that is what these are the non-deterministic approaches to solve it. Cool. By the way, there is of late somebody discovered a very efficient approach to handle collision, and that is by using mixture of this and this. You do not know this, so you might not be able to relate to it, but there is no need to know this. Instead of this, can I use some other data structure in which search becomes very easy? My question is that here to handle the collision, you used a linked list for chaining. Now search in linked list is order n. So can you use some other data structure where search is faster? Yes, you can use BST. You can actually use BST for this case. So what would happen is that here I told this is self-balancing BST. Now, although we haven't told you this till now, but what BST does, if there is a key, everything greater than this key is in the right, and everything smaller than this key is in the left. So let's say smaller than this is 10, and it applies for every node. So if something is greater than 10 but smaller than 17, it would come over here. 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 This is how BST is implemented. So cool, that is a good point. The search in BST is order n in worst case, but I mentioned one point over here, self-balancing BST, which always ensures that its height is always balanced. Balanced means that the height will always be of the order of log n, right? So if the height is always of order log n, the search process in a BST takes order of h time, where h is the height. And if the height is always log n, then the search will also always be log n, right? So what do? That they will do the chaining, but instead of creating a linked list, they'll create a self-balancing BST, and it will be done on basis of key. So if let's say something like 11-0 came, then it would come over here, it would be this child, and something like let's say 1-5 came, then it will come over here, and this is how it will go. So from every node there is a tree that is exploding out from there, and that is a self-balancing BST. So if you use something like this, then your insertion and deletion every time, sorry, not every time, in the worst case, in case of this, will be how much? Yeah, it will be log n. Your search or delete, or insert anything, in the worst case, it will be log n. Okay, so now what is a tree map? Let us understand that also. Tree map is nothing but this, literally. Tree map is just remove everything, and just have this much. This is what a tree map is. It is just a tree. It is just a balanced binary search tree, self-balancing binary search tree, which always maintains the height and stores the key value pair in the sorted order. So this is what tree map is. So it actually is not a map. It is called map because it stores key value, but because of its structure, it is actually nothing but a tree. So can you tell me what will be the time complexity of insert or search in an ordered map, which actually uses tree map implementation? It will be log n always, yes or no? It will always be log n, okay? But if you're using a hash map, how much will be what will be your best case? Your best case will be order 1, but your worst case will be order n, right? But because of the robust hash function, amortized complexity is order 1. So this is preferred generally, okay, to speed up your algorithm. So there is an important task for you, just write it down. Whichever language you use, be it Java, C++, you have to read the implementation of maps in them. If you're using Java, read about HashMap and read about TreeMap, how they work. And if you're using C++, read about ordered and unordered map, how they, so you know how they work, but you have to learn about their syntax, that if you have to insert something, then how to insert, if you have to delete something, how do you delete.